Okay, so this is a short part, the ending part of this series, part three. In the previous video, I realized there was a mistake, hence the abrupt catch. That's why I ended the last session. So we will continue, and I'll point out why I think there was a mistake in the computation, which have been corrected. So let's jump right back in. So with the duration here, we find out that the duration, there was a mistake with the duration. So we will not depend on the duration. We would rather depend on the duration, which is also the same as the days traveled by the resultant vector. So instead of 342, you see there was a 159 here. So there was a computational error here, but we will rely on the resultant vector here, which is the same value as the durations here if we check them again, right? Which is the same values here, right? So we see that um, this resultant vectors here are very important in how our prediction is a breakthrough, right? When we add these resultant vectors here together, this will give a phi division for if sorry if we add the vectors in the first three, right, or the durations, or in the first three cycles, both the vectors and their duration should be a phi expansion of these two vectors, similar to this point, right? So we can check that um, when we add these durations here together here, we get a value when we divide by 357, we should get a phi or a 0.618, right? When we add similarly, when we add the durations in the last two cycles and we divide by what we have in the predicted, we should also give a phi expansion, right? And we also point out that the relationship between these two vector here is a root 5, right? We have we can see how the root 5 is intertwined with the golden ratio in this table, right? This is a very informative condensed table. I think I should be making another video explaining step by step why I think this is very informative and how we may draw various conclusions from this table. Now we will also look at a more generalized table which include all the various vectors here. Now you can see the analysis is done for 10 cycles, right? So for all the 10 cycles, right, not only the similar cycles, but for all the 10 cycles starting from the origin, which is the 2015 origin, we have all the 10 cycles, and um, we can see we are getting the same predicted downward, right, and similar resultant, right? So even though we didn't use just the similar ones, adding all the dimensions, the 10-dimensional parameters, we still have the same results as the three-dimensional parameters that we were using. So this uh, adds up to what we were talking about. Add even though when we add all up together, our model is still powerful, giving us the same what results, right? Okay, we will not talk about the ellipse here. So that's what I wanted to show you. So now, since we have the PTV in mind, we should be able to model a subspace where the particle should travel. If we look at this point here, right, right, with a PTV, we can see there should be a boundary, right? There's always a boundary. We do not expect price and time to move away from, right? Right. So we are trying to find a boundary that however the particle may move within this boundary, we should expect that the terminal point should be 420 units, right? Either way, however, haphazardly it may move or can move around within that subspace. We should expect the total eight endpoint to be 420 units, right? So that is what we are trying to do here. So we would look at another different chart here, and with this chart here, we there's one other assumption. So we would five rectangle where we use our predicted time and predicted change in price to draw a root 5 rectangle, right? Again, when we check the duration, you can see duration. What? Okay, okay. When you check the duration here, you can see we have 184 days, right? It's the same as how you predicted, right? The our prediction 183 days, right? And we look at the change in price too. We have to see change in price. The relational ratio is a root 5 what rectangle. So it's a root 5 rectangle. Actual root 5 rectangle should be 402. Hence the extension of this rectangle 408. That is the actual root 5 rectangle. Right? So it's a little variation. So when we draw this rectangle, we expect price to move this model the boundaries and the model the expected behavior and how how we expect price to react at any point at or different times. You can see the reactions around the curves drawn here and reactions at the boundary points. Reactions at the boundary points, reaction at the major axis and the minor axis, right? Reactions at these sections. These sections are the square or um, um, the square divisions of a rectangle, right? It's quite unusual, but if you actually know what you are looking for, you can tweak around some theories in your best favor, right? So with this in mind, we can model how we expect the price to move, right? We don't expect it to move outside of this area. This is where we expect it to move until it finally reaches this point in time. So we come to the section where we ask ourselves, why is 7th July an important date? Where real reason is quite beyond our discussion, but I'll point out that when we draw the fifth time zone between these 2 points, right, we find out that 7th July is 7 July is at the zero point 0.5 area, right? 7 July is at the zero point 0.5 area. How did we realize again? We also realize that the 0.330 was this rule here, right? And this mark important points within the gold market, right? Again, when okay, so we will talk about more interesting stuff maybe later